Hey, welcome. As you can see, I'm in my lab here at the school where I'm at, and I got a few things, kind of fun toys, and we're at a point where we're talking. We've just finished up with how do you deal with motion. That motion is a vector, and they can be, caused and gone in certain directions. We use the kinematic equations to predict where that motion ends up sending you, your position, your velocity, your acceleration or time. We learned in the last few days that forces are what cause motion. Force is equals a mass times acceleration. Those are great for saying, if I'm going to push a car or put jet behind a jet engine behind a vehicle to send that off in a place. But what happens when one object collides with another? What we've realized is that what we need to describe that isn't just the velocity, but it's a product of the mass and velocity. Okay, if you're a football player, you've ever had a sport like rugby, or you've got to get in and, or you've had a small car and you've painfully aware that you need to understand there's momentum that's necessary, and momentum is what governs collisions. So if there's a collision, you got to think momentum, momentum. Now what I've got right here is called a Newton's cradle. Seems like he's everywhere, isn't he? Last couple of units. Newton's cradle is interesting is that I've got little spheres like pool balls that are here, and they're going to collide into each other, and there should be a rule we should be able to see. So if I take one of these spheres and I send it into the middle, ideally what you're going to see is that one ends up coming out the other side. Now it's a little off, so it doesn't quite go. I'm going to pull that just ever so slightly and see if I can't get us to get a little better reaction here. One going in, one going out. Okay, is that a general rule? Momentum in has to be momentum out. Well, let's take two of these and let's see what happens when we send two down the pipe. Two go in, two come out. Would it be the same with three? I mean, we've only got four here. Well, let's see what happens. I'm going to pull three back. Stop that motion right there. Three go in, three go out. And so we seem to be onto something, a kind of universal rule about how momentum works. Momentum is always conserved in collisions. Okay, so we add whatever momentum you go in with, it's got to be the same as the output. And so that's where it's going to govern the kinds of problems we do. Let's take a look at some of the formulas and we'll see if we can't help you to get set up for the problems that we do.